Hello, class. Happy Thursday. As with your Thursdays are the new chemistry things that are going on in the world, and here is an article about a new antibiotic. So there's a couple of things that's cool about this. First of all, it's in the shape of a lasso. So I'll show you here. Here it is. You can see there's a ring here, and then it has I'm almost gonna call it a tail, but like a longer rope. So it's a lasso. It's also kind of small. These are amino acids here. So this is a pretty small molecule here. Another cool thing about it, it was found in someone's backyard. Literally dug up and looked at a soil sample, and they found this molecule. And well, I guess it's a peptide. Well, I guess that's still a molecule, but it's this small protein, a peptide, and it turns out to have antibacterial qualities, specifically. So the way that for humans, mammals, and most things except for plants, although this still is true for plants, our structure comes from proteins. Also for plants, the motions, everything comes from proteins. So plants have cellulose; they can use that for some of their structure. It's in their cell wall, and bigger plants, of course, things like that. That's macrostructured parts as well. But for us humans and for bacteria, many others, we just have protein. And also enzymes also found in plants. So this is in all living creatures that we know about. That there's enzymes, and those are made of proteins. So if you mess up these proteins, it causes great harm to the organism and or microorganism. And what this lasso peptide does, it inhibits a specific site on the ribosome of bacteria. And also it seems to be broad spectrum across both gram-positive and gram-negative bacteria. So what is gram-positive and gram-negative? There's a stain called the Gram test, and if it stains the bacteria, it's gram-positive. If it doesn't stain the bacteria, it's gram-negative. So, and what does that mean? Well, generally speaking, they do different things. So gram-positive bacteria, these tend to be your upper respiratory system things. So like the pneumonia, these kind of things. Staph is also gram-positive. So those kind of diseases tend to be gram-positive. Gram-negative, these tend to be more in like the GI tract. Those bacteria, those infections tend to be there. And generally speaking, antibiotics or antibacterials tend to work better under certain types of bacteria. So penicillin, amoxicillin, azithromycin, those tend to work better for gram-positive. Sulfonamide, Cipro, Levaquin, and the fluoroquinones, those tend to work better against gram-negative. This one seems to work against both. And also some definitions. So there's antibacterials. These are drugs that kill bacteria. And then there's antibiotics. These are also antibacterials, but they work by inhibiting some sort of growth mechanism and then also working in tandem with the immune system, typically to finish off a bacterial infection. So this is an antibiotic, so which is inhibits something to do with the growth, and specifically it interferes with protein synthesis. And it doesn't interfere with human protein synthesis, but only broad-spectrum bacterial protein synthesis. So in the article, it goes over this. To give you the idea, the way proteins are stored and in the hereditary material, they're coated by nitrogen bases in the DNA. So DNA unzips and messenger RNA or mRNA forms over the DNA, and then the mRNA goes to the ribosomal RNA, and in tandem with the transverse RNA, then the ribosomal RNA will use the transverse RNA to with the coding from the mRNA. There are three different nitrogen bases that have the coding for the different amino acids, and then proteins are synthesized that way. So that's how cells make protein. And what this lasso does, it interferes with the receptor site for the ribosome in bacteria, and because of that, it makes the proteins built improperly. And I mean, you could say, oh, it's a mutation. We'll have super proteins, and chances are no. Chances are no. It always destroys. I mean, radiation doesn't give you superpowers. I mean, that can cause mutations too, but it gives you bad things. So generally speaking, mutations are a bad thing. And so this one changes the shapes of the proteins by how they're made. And if they're made improperly, they don't function as well, which will eventually lead to the death of the bacterium. So that's how this process works. And this is also important because we're getting more and more resistant bacteria to drugs. And so because of that, here's something that's new, and it's going to kill certain bacteria. And there's bacteria like MRSA. I've heard of MRSA that tends to be resistant to many antibiotics. So this is interesting, and this is also, it was found in someone's backyard, and then we're turning into a drug. And I know I've given talks on, like short talks like these on how we're using AI to find things, and also certain things like the protease inhibitors for antivirals. So we are looking for drugs using really targeted things, and this one I don't want to say it's by accident, but it's kind of a discovery. It reminds me of the discovery of penicillin. Where they found out this mold seems to inhibit the growth of the bacteria, and it was because of penicillin. And so this is an interesting thing, and nice little article. So hopefully it gets you excited about science and how science is improving your quality of life. This is not a drug you're going to find yet. So this is something, it hasn't been gone through all the testing. So this is not on the market, but this is more like, we've discovered this lasso-shaped peptide that probably can be used as an antibiotic. So that's kind of cool. So hope you enjoyed the article, and I hope you are doing very well. If you find yourself not doing well, like if you're not having your basic needs being met, if you're dealing with crippling mental health issues, if you're having academic problems or anything else that you need help with, feel free to reach out to me. I will do what I can to help. Have a nice rest of your week then. Aloha.